Hello guys, I'm sorry, really sorry for the delay. I was little busy with some stuffs because today is Diwali, so I needed to prepare something. So, so now I'm it's done. Happy Diwali to all of you, and I hope today you all will enjoy most probably. So I was thinking means I will also enjoy, of course, but. Uh, Before that, I thought of giving DSA some priority, and then we'll celebrate Diwali in the evening. So this is something that I wanted to do. So and here I am. So today also we'll be starting with some MAANG companies. Okay, questions related to that. What I was thinking of. uh, uh, Trying to do the contest problems first. I was thinking of doing some contest problems, uh, or maybe to just go into the flow of coding. I'll start picking one or two questions from Google, I would say, and then after that I'll try to pick uh, the lead code questions. So I was thinking of filtering it as a full stack, maybe. Okay. Okay. So without wasting any time, we'll just continue because I've already wasted half an hour. So I don't want this to happen again. So okay. Mm, Actually, I was solving this vertical order traversal of a binary tree last time. Height of a binary tree after subtree removal queries. This is also one of the finest question I would say I solved recently. Cousins of binary tree too. It's also really good questions. So uh, okay, something I would say majority element is similar. Lexicographically smallest beautiful string. This has a really good concept. I would say how to handle the palindromic part was really good, beautifully handled in this question. I would say means if you need to know more insights on how palindrome part works, I would say you should try this question. I tried this yesterday, or I think yes, I solved this yesterday, and it was really amazing to solve these questions. Yeah, even though I was not able to solve it by myself, I saw one or two YouTube videos and submissions, but yes, I was there, very close. Okay, so sorry, my throat is little. Okay, let's go with the say contest question. Let's pick problems from contest. No, contest. Let's pick up bi-weekly. I did not give this. Okay. Let's try. So I'll try to solve this, then this, then this. I'm not picking up the first question because it's already easy question. So I don't want to do that. So let me open my. Okay, so the contest started. Let's give virtual contest. I'm really sorry for my throat. Please bear with me. I don't know why this is happening, but this is happening. So let's start. Okay, I have timer for contest, so I don't want this. Okay, fine. So find subtree sizes after changes. Okay, let's see what this question is saying. You are given a tree rooted at node 0. Okay, I have been given a tree rooted at node 0 that consists of n nodes numbered from 0 to n minus 1. Okay, okay. So if there are 4 nodes, then it will be from 0 to 3. Fine. The tree is represented by an array parent of size n. Okay, okay. Where parent of I. So the tree is somehow represented in an array where parent of I is the parent of the ith node. Okay. So I'm guessing this will be my node actual node, and the value inside of it is the parent. So eventually my node 0's parent will be -1. Correct, because there is no parent for node 0. 1 2 3 4 0 1 1 1. Okay, so this is what my tree parent tree look like. And what's next? You're also given a string s of length n. Okay, it's the same length as the number of nodes. Okay, where s of I is the character assigned to the node I. Okay, so I have been given a s also, which is a b c, which is same as my means 0 is assigned value a, 1 is assigned node 1 is assigned value b, and it will be something like that. Okay, we make the following changes on the tree one time simultaneously for all node x. Okay, we make the following changes on the tree. Okay, we are making our following changes on the tree one time simultaneously. Okay, one time simultaneously. Let's see what this means. For all node x from 1 to n minus 1. So from 1 to n minus 1, we are not talking about 0 to n minus 1, we are talking about 1 to n minus 1. Okay, so we are not considering the parent, we are sorry, the root node we are not considering here. Whatever we are applying the changes, we are starting from its child. Okay. Okay, what is the changes that we are applying? Find the closest node y. Find the closest node y to node x. Suppose this is node x, so I need to find the closest node y, which is closest to x, such that y is an ancestor of x. Okay, y should be ancestor of x. So that means this child part is gone. I think this will be the ancestor, the parent is the ancestor of x, and s of x is equals to s of y. Okay, s of x is equals to s of y. Okay, I need to find a ancestor of x such that the values, the this characters should be same. Obviously, we will not be able to find ancestor of root node, because there is no ancestor. That's why we are starting from 1. Okay, fine. Let's see. If node y does not exist, if there is no ancestor whose value is same, I have to do nothing. Okay, fine. Otherwise, remove the edge between x and its current parent and make node y the new parent of x by adding an edge between them. Okay, so we are not handling any of kind of binary tree. Okay, it's a simply tree, so it can have multiple childs, right? Return an array answer of size n where answer I is the size of the subtree rooted at node I in the final tree. Okay, maybe it's not very much clear to me what we are doing, so I would try to do it with an example, probably. So we have this as example. So if we draw this, 0 will have no parent, 1 node 1 will have this, node 2 will have this, 3 has a child. Okay, so S is A, B, C. Okay, A, B, A, B, C. So we have this as a node. This is a tree that we are dealing with right now. What it is saying, ancestor. And for 0 it's 1 2 3 4 5 4 5 and 6. For 1 it's 3. For 2 for 2 it is 0. Find the closest node y to node x such that y is ancestor, and the values are also same. Otherwise, remove the edge between x and its current parent and make a node y, and make node y the new parent of x by adding an edge between them. So if I remove this, I have to add this only. That's what it's saying. So for this, for 2 0 1 2, the answer is 1. The size of the subtree rooted. Okay. For 3, who is the ancestor of 3? Mm, A is the ancestor for 3. So I'll remove this edge, and I'll somehow make this as edge. So for 0, 3 is the new edge with the value A. And if there is a no, so for 1 it's 1 2 3. For A it's 1 2 3 4 5 6. For 2 it is alone himself. For 3 it is alone himself. For 4 it is alone. For 5 it is alone. So I think somehow this is a uh, tree that we are talking about. Okay. Okay. Let's see example 2. Let's remove this. Example 2 says 0, there is no parent. One's parent is 0. Two's parent is 4. Third's parent is 0. And fourth parent is 1. Okay. So it is something like this. And the values are for 0 it's A, 1 it's B, 2 it's B, 3 it's B, and 4 it's A. Okay, so total number of nodes, how many total number of nodes are there? It's 10 to the power 5. So we need to somehow uh, we need to know what is for this position. If I'm at this position, I need to know uh, is there any value A present above this who can be its ancestor. Means overall we need to segregate A's, we need to segregate B's together. So whosoever is the first time we are encountering we can segregate A to A there. So A will be like this. 4 will detach from here. It will attach here. Now after detaching 4, the parent of 4 will change from node 1 to node 0. The parent of 2 will change from node 4 to node 1. Yes. So this will also change. So these are the two changes that we are doing. So that means we are kind of segregating things together. And then for A, for root node, it'll always be all the nodes. So for root, I don't have to do anything. It's the total count of nodes: one, 2, 3, 4, 5. For root, it will be 5 always. On left, if I go to 1, left I have 1. It's B. So how many B's were there on left? Everything will attach to this B. Means after this, how many B's were there? All the B will be attached here. So 2. It's only 2. Now from 1 I can. How many nodes were there after 4 who all were A? So if there are multiple A's, it's I need to find its ancestor, not the toppest ancestor. It's just current closest ancestor that we are talking about. Find the closest Y. Y is an ancestor, so closest ancestor. So for 4, so somehow we need to know for A how many nodes are there below it who all are A. So even there's nothing. I need to add it also in our answer. This was the case when C had uh, no ancestor. Okay, so if we try to traverse it recursively from either calling from front or reversing from back, will help me. So if I try to recurse it from back, I know from 3 I don't have anywhere to go. It's kind of 0 has a child of 1. One from 1 I. From 1 I can go to 0. From 2 also I can sorry, 0 is the parent, so from 0 I can go to 1, from 0 I can go to 2. This is what I'm creating for now. Let's see if this will help me or not. From 1 I can go to 3, from 1 I can go to 4, from 1 I can go to 5. So this is my root node where I can go. So 3 I cannot go anywhere, 4 I cannot go anywhere, 5 I cannot go anywhere. So while returning back, we'll return 0 0 from left and right. I know there is no node below this, so while creating my answer 0 1 2 3 4 5, there were a total of 6 nodes, correct? Okay, so for 3, there is only one. There is no node below it, so only one. So for 3, answer is only one. For 4, answer is only one. For 5, answer is only one. Sorry, for 5, answer is only one. Okay, now we are traveling back, taking 1, 0 plus 0 plus this as 1 over here. From here, I'm going back from node 4 also, and from 5 also we are going back. I saw its parent. Maybe 1a. How many a's? How many a's we have? How many b's we have? How many c's we have? But there is one thing while recursing back. I'm telling there were 1a, 1b, and 1c below of it. So I'll check this. Okay, this is b. So I'll say that, okay, at this position, add b. What will happen when I start from top? I have the same thing. I'm getting stuck at the extra characters. Okay. I have this as b, this as a. I don't know if there is a that is present before this. It might be the tree would have something look like this kind of. The values might differ. That is not an issue. Something like looked like this, and instead of this, there would have been C, and here it would have been A. Exactly, we are doing here is something what I'm missing. So whatever value b will contain, the above b will contain exactly same value, because this will get attached over there. Hmm, nice one. What's the trick over here? What is the trick over here? This 3 will be attached over here, right? That means this A, and this 3 will be detached So B has nothing, no, nothing now. Maybe we can do some pre-calculation or something like that, which will help me to know. Help me to know how many A's are there below it. I'm getting a little confused over here. Okay, here uh, 4. Do I even need to do this? What will happen if there is C? This was C and this was C. So A, it's fine. This A will be detached from here and it will go here. Everything is getting detached. So, but if there would have been a C, what will happen then? If there would have been a C, maybe 5 with C, this A will parents will detach and it will go here, right? But this C will be attached with 4 only. So in that case, if the tree will somewhat look like uh, हैप्पी दिवाली स्ट्रीम प्रसून भाई. क्या हाल भाई आज भी. अरे बॉम्ब फोड़ो यार. I need to have these two detached and over here 4 as well as 5. And if this would have been a D, घर नहीं गए. नहीं ब्रो, घर तो नहीं गया मैं. तभी तो स्ट्रीम कर रहा. घर पे होता तो नहीं करता भी नहीं. It's not very much. The picture is not getting clear in my mind. What will happen uh, to this node if there is nothing? So this will get attached to one only, or it. सब ठीक है ना? घर क्यों नहीं गए? हाँ भाई, सब ठीक है। ऐसा कोई इशू नहीं है घर। बस इसी तरह कुछ कुछ प्लान्स में चेंज है। जाऊंगा अभी कुछ टाइम बाद। टिकट करवाऊँ बताओ? जुगाड़ है सत्तू भाई का। सत्तू भाई? ये सत्तू भाई कौन है? So before detaching A here, I would have detached this two over here. So I will. I'm thinking of starting from back only. Recursively, we will go from back, and we need to know its ancestor, right? This value. Where is this value? Just above two. Okay, I need to know this B ancestor. So I need to somehow like need to know what is the current just above ancestor. So that I have to handle it before this only. So maybe I'll traverse the tree. I'll start I'll start keeping the ancestor. So for node 2, I have B. Who is the ancestor of B before node 2? It's something like that. So I need to handle these two things together because I need to know ancestor of same ancestor. Okay, let's try it. Let's try it. Let's picturize it and keep it somewhere. So I have node 2 has B, and currently there is like node string and an sister. Don't mind my spelling, I'm sorry. Ancestor, there is no ancestor for this yet. Okay, same thing for C. For 5, node 5, C, who is the ancestor? No one. Okay, we went back to 4. 4 A. Is there any was there any 4 earlier? No. How can we handle? We need to know by B only. So I can't. I'll have to do it by strings, not just the opposite way. String, node, and ancestor. So maybe string, node, and its ancestor. So string is nothing but B. 2, there's no ancestor. C, 5, there's no ancestor. A, no, A was not encountered yet. 4, no ancestor. Now we have B. I saw this B. I saw this B before. Is there any ancestor of B? Is there any ancestor of B? Is it so? Just there is a latest value which is 2. So for 1, so, I think this will detach and it will attach to 1, right? This is what I'm thinking right now. So this will detach and attach to 1. So I'm pretty much sure that 1 has that means now 2's parent is 1. So I can change in my string that okay, I can change in this parent string. One, two, three, four. Earlier it was no, sorry, it's not something like this. This is the example that I took. 0, 1, 2, 3, 4. So 0's parent is -1, 0, 4, 0, 1. So I saw this B earlier, and this is the latest parent for this node. So what I will say that now the new parent for 2 is 1. So new parent for 2 was earlier 4. Now it will change to 1. Let's see how this pans out. We have already seen. So this is now this will change to 1. Now we fall back. Did we see A earlier? Yes, we saw A earlier. So A was a node 4. Now node 4's parent will be 0 now. So node 4 parent will be 0. Now we had one more. 5 parent was 4. So and this will be updated with node 0. So there is one thing that this B, the ancestor for B is not 1. So maybe I'll handle left part from root separately and the right part from root separately. Means uh, there'll be all the things will be, all the nodes we are attaching will be because it's a tree, so it will never be something like that. Now okay, now what will happen, B is okay, let's see now our I made this as a new parent, and now according to this, what tree, how tree will look like. For 0 there will be nothing, 1 will be connected with 0, fine. 2 will be connected with 1, 2 will be connected with parent 1, 2 is B, fine. 3 will be connected with 0, 3 will be connected with 0, and 4 will be connected with 0, 4 will be connected with 0, 4 is A, and 5 will be connected with 4. So for this, if I now I go and fill up my answer array 0 1 2 3 4 5. So for 5 there is no node, so for 5 it's 1, will return back 1. For 4 it's 2, for 4 it's 2, will return back with 2 over here. We'll call this for 2 it's 1 again, for 2 it's 1, will fall back, we have a 1 with plus 1, so 1 will be sent away, 1 plus 1 that is 2, so for 1 it's 2, and will fall back again with 1 plus 1 that is 2, 2 over here, so 2 plus 2 will be added from here. For 3 it's 1, 1 will be sent over here, so 2 plus 2 plus 1 plus 1 5, and plus 1 that is 6, so 1 2 3 4 5 6, total will be 6 over here. So this is my answer. Oh god. So this is how uh, I think I can do it. I'm not sure if we need to create a adjacency list for this. Let's if we could have handled it without adjacency list. Okay, so let's create a adjacency list for now. So vector int adj list, adjacency list, we have adjacency list as will be size of parent, total number of nodes. So let's take n as parent dot size. This will be adjacency list of total n size. Now I will iterate over this. iterate over this parent node, and for the first, like, parent and its child, I'm talking about parent and its child. So for first node there will be nothing, so I may just start directly by this next node. So for adjacency, list of nums of I dot push back I. Parent of I dot push back I. So this will do what? For 0 it will push 1. So for 0 it will push 3, for 0 it will push 4. So it will be it will be the adjacency list. Now for 0 child, for every child I will have some different maps. This is the only thing that I am thinking of how to handle it. Is it fine to call separate calls, or should I go with the same call? Uh, because from 0, if I'm calling this, I do not know about this branch. I own this is a separate, and this is separate, right? 3 is not getting attached. So for one uh, parent 4 will be attached from node 1 to node 0. Parent of node 2 will change from node 4 to node 1. That is the only thing that I am skeptical about, how to handle that part. How to handle this every calls from 0 should be in a separate way, because have this string and a character as well as node thing. So for 3 it's uh, so what I actually want is for these only. For a it will always be all the values. It won't matter. Oh, this should be something smaller. I know I can solve this code. I know now. I know the logic how we are dealing with, but the code that I am thinking, the way I'm thinking to approach this is somewhat wrong. I will code it, but it will be very long code. I don't want that longer code. I want a shorter code. Means first I'm creating adjacency list, and then I'm changing this parent, and then from this parent thing I'll again change to adjacency list, and again I'll do the normal iteration. The two iteration I need it. But for every child, right, it will be changed over there. Can I directly do with parents only? For node 0, which child I can go? 1 I can go 3, but this is kind of iteration which I don't want. I'll have to create adjacency list for this. Okay, let's do it. Let's try it. Let's try it. Parent adjacency list. I have created my adjacency list. Now all the childs of 0 I'll call, and I'll do the same thing. So for I is equals to 0, I is lesser than adj list of 0 dot size plus I. Now what will happen is erase few things. This child I will change my parent. I will be having an unordered map, unordered map of character corresponding to integer. This will this is kind of ancestor, and it's kind of pre-calculate kind of thing, where I will send this adjacency list of 0 of I. This is my node where I will start everything from where I need this ADJ list as well as this A and C to populate. Let's see what this will do. This will calculate, this pre-calculate will do all the job, and after coming back here I need to do the same thing for the root node. So this A and C will be filled up. Now I need to check what character 0 contains. So I need to send my S also here. So if A and C dot find S of 0 is not equals to ancestor dot end, that means that ancestor is present over here. So what I will do, that node's ancestor will be this. So what will happen is I need to send parent also. So parent of parent of ancestor of S of, sorry, not S of 0, ancestor of 0. I'm saying S of 0, this character ancestor is something. So parent of 2 is 1. Is 0. Let me check parent of ancestor of S of 0. S of 0 will give me the character. I'll find in my map what is the value. So 2's parent. So I'm going to 2 index, second index, whatever value it contains, I'll update that value with 0. And after this A and C dot clear, and I'll call again. So I'll clear that part. Now this pre-calculate. So I have this node, I have this adjacency list passed by address. I have this ancestor map also passed by address. I have this string also passed by address, and I need to know the parent also. So I need to pass this parent also. uh, I'm pretty much sure there should be something very smaller code, very less code written, and could have been solved in very lesser amount of code. But it's fine. Let's see. Okay, so I have this node. So what I'm doing is I'm iterating over the adj list of node dot size plus I. So for 2, if there is nothing, means after this excuse me, sorry. So for 2, if there is nothing present, what I would say, I would check in my map, in sister map, that this node's character, this character is present in my map or not. So I'll check my ancestor map dot find s of node is not equals to ancestor dot end, means this character is present. That means I need to do something. I need to update in my map also, as well as I'll be updating in my parent also. So parent will be something, parent of a and c of this node, and sister of not this node but s of node. So ancestor map contains the string, so I provided this node is already present. Was this s of node was already there, right? So ancestor of s of node, I went to that parent, and what I'll say is update it with this new parent. New parent is what? Current node, and same thing will be updated in ancestor of s of node with this current node. That now this is the new parent, and I'll return back. And now I'll do the pre. If it does not contain, that means this is the first time that I'm encountering with this new character. So what I will do, ancestor of this of is of node with node, right, corresponding to this character. So these two are same redundant thing. So let's make it. I'll do the pre-calculate part. The new node will be adjacency list of node of I have this adjacency list, I have this ancestor map, I have this S and parent. So I went to the new node with the everything, rest of the things kept same. So this is what pre-calculate will do. Now I just have to iterate and create our answer. So after this I need to create another adjacency list based on this new parent that we have. So it'll be same thing, adjacency list, maybe new adjacency list. I just need to sum and place it, and I need a vector int result. It will be of size and initialized everything with 1. Normal DFS sum. I'll start with node 0. I'll send this adjacency list new there, and this result will also be there. At last I'll return my result. I need this DFS sum. So this will return integer type. I'm having node, current node, this new adjacency list passed by address. I have this vector int % as result. So that should be 1 because we don't have any stopping condition. So adjacency list new of node dot size plus I int new node is something adjacency list new node of I answer is equals to answer plus DFS sum, new node adjacency list of new and result, and after everything I will do what result of this node is this answer, and return answer. Okay, I have a little doubt on the things that I did here. Maybe this will, I need to check it twice. Let's run this and see. There is some compilation error. A and C. What on line 40, 40, 40, 40. So 63, is it so? 631111, correct? 52111, 52111. Okay, okay, great. Okay, this worked. Sure, let's try and submit it. See. Okay. Okay. What's 19115, and after that everything deferred. What should I draw this? I think the problem that I can face is not with the logic that I am doing, is because I don't have much examples here, that when this will happen then what should I do in that case. That is where I'm little confused, that whether that should be the case or not. Drawing this, okay. What I can do is, let's take a 10-minute of break, and after that I'll come back. It should not be something like this, should be simple. DFS, right? It is a DFS. Yes, it is a long code. I am getting this DFS, and then it will be simply counting children. What I am doing is the same thing. I'm counting children over here. This is my DFS of counting children, and this is my pre-calculate part. So rearrange the edges and create a new graph and count children. Exactly, this is what I did. Rearranging the new call the this. Okay, I'll take a 10 minutes break. I'll try to uh, go with this example and figure out what is the mistake that I'm doing. There should be some silly mistake that I'm doing. I'm pretty much sure about it. Uh, let's see. Okay, I'll be back in 10 minutes. Don't go anywhere, and then we'll continue. back. Okay, so where were we? Let's try to draw this. Let's see what why we are facing this. Mm, just wanna add one or two more test cases by myself. D E F G H. Okay. 3, 4, 5, 6, 7, 8, 9, 10. This is also working. Are we handling any kind of disjoint tree? Is it so? It might be possible that we are handling any kind of disjoint. So if we remove 4 from last, even 5 from last, and 1, 2, 3, 4, 5. Let's see. I need to short. I'm trying to short this. Okay. Can I make it more short? So if I'm removing 4, so 13 minus that is everything should be 9. 9, let it be 8, let it be 9, 7, 8, or 9, 7. Okay, sorry. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Let's see. Parent does not represent a valid tree. Okay, fine. Okay, let's draw this. We have 0. We have Zero's parent, one parent is 10. So one's parent is 10. Two's parent is 0. Two's parent is 0. One's parent is 10. Let's separate it out. Three's parent is 12. Three's parent is 12. Four's parent is 10. So four's parent is 10. Fifth parent is 13. Sixth parent is 11. Seventh parent is 12. Seventh parent is 12. Eighth parent is 2. Ninth parent is 3. Where is 10th parent is 2. We saw this 10th. Okay. So 10, 4 and 1. So 10th parent is 2. 11th parent is also 2. 11th parent is also 2. So 11 and then 6. 12th parent is also 2. Okay. 12 and then 7, then 3, then 9, and 13th parent is 0. So 13 and 5. Okay. Huge tree. Let's write the numbers. For 0 it's B. For 1 it's A. Where is 1? For 2 it's B. For 3 it's A. 0, 1, 2, 3. For 4 it's D. For 4 it's D. I don't know why I'm doing this, but I need to know the reason. For 5 it's A. For 6 it's B. For 7 it's B. For 8 it's D. D. For 9 it's A. For 9 it's A. For 10 it's B. 10 it's B. For 11 it's C. For 12 it's B. And for 13 it's A. Okay. So this is how my graph looks like. Okay. Okay. What is the answer that we are getting? For node 0, We are getting 14, it's fine. For node 1, we only have 1. For node 2, we have 11. For node 3, there is something problem. Hey, it should be 2. Ah, here it goes. Here it is. Okay, now I got the reason. I shouldn't be handling that thing. Uh, okay, so the first thing that we are doing is somewhat a mistake. Okay. Rest of the thing is fine. I need to handle this pre-calculate part. I handled it very badly, very badly. I should improve. I should improvise on this. This pre-calculate part is wrong. Okay. We have something like characters, so we can create a 26 size uh, array characters, a vector of size 26. It's something like from here, if we call this root, this will return something. From here, if we call this root, this will return something. From left, whatever we are getting from left, whatever we are getting from right, we'll merge that and then we'll go back. So it's something, whatever we are getting from left, whatever we are getting from right, we'll merge that, we'll go back. And from here, whatever we are getting from each and everything, will merge everything and will get back to this position. And then for right, whenever we are calling right. Okay, okay. This pre-calculate, can I make it a better way to handle it? Hmm. How come these many people are able to solve this question so fast? 2000 were okay. It's like something that I am missing. That is the reason. Handling this parent shouldn't be that much difficult. How I am thinking right now. Is actually handling this map. Node and new parent used to record. Map of 26 size array to keep track of the last. Aha! What exactly I was thinking is told by him. Means we need to keep track of 26 array size vector. Okay, can we do this? Can we try this? Let's try this. Recalculate something, and also I don't need this, and also I don't need this. Also I don't need this ANC and sister map. I don't need this, so there is no ancestor map here present. No ancestor. Nothing related to ancestor. Let's for now let us keep it here. Okay. This will return ancestor. So if we have nothing from 7 to go, from 7 I went I'll return an ancestor of empty. This from right also, like from here nothing is there. I'll return an ancestor of empty from here, which eventually I'll store over here, whatever we are getting. Current child uh, something. So we got, this is something we got from child. Now current ancestor will be populated with this child. So uh, what will happen over here populating this current ancestor, like suppose from here we are traveling back. So mm, so from, suppose this is C, it was B. Now let's suppose this is C for now. So this will have a ancestor, I'm fine with that. It will get a child, where what will happen is I'll get 0 1 2 3 4 5 B. B is nothing but this index. This index is denoting my character. So this character will have 7 as node. Correct. I see at this position that B is already not 0. That means it is populated. So what I will do, I'll change the parent of 7 to 2. Parent of 7 will be changed to 2. This is what I will be doing. So, after getting this, I will call process child. So I have this position as an ancestor. So from child we are getting something. Okay. So before processing child, I'll check whether this node will have a character. So let's take this character. S of node position will give me this character. Now, whatever we got from child, so child at this position, because only I need to change one thing. So if so everywhere, what I need is something better. At this position, what I will get? At position B, will get 7. At A, what should I be having? 3. At A, we have 3. So if this is B, it should be 12. But if this was also B and this was also B, what I would have updated here. From here we are getting 1 as 7. From this side we are getting 1 as 3. Now what? Now how to combine this? And suppose this is some other character A. So this B will also be connected with this A will also be connected with this, right? Creating a 26 array size array will not help me. I should have Node and character should have kind of character and corresponding to that node list. So A has 5. Okay. So from here, if we say B has a node list of 7, which I'll return back as B contains 7. From here we will say A contains 9, which I'll return back. Now A contains 3 instead of 9. I'll go back to here. If suppose this was A or maybe C, if I'm guessing this to be C, we have kind of B, we we got B as 7 from left, from this, A as 3 from this, and if suppose this was B3, this was B3, so we're getting B as 3 from here. So I'll have to combine this, means what I'll return to this as B is there for 7 and 3 both, which will be returned over here. So now 7's parent will also become 2, 3's parent will also be 2. Give me a minute. There is someone at the door. I'll be back in a minute. back. Okay, I think I should see the solution for this. I'm not sure this pre-calculation part is something that I need to understand properly. Not going with him. Is there anyone disjoint set kind of approach? Mm. So this is a new parent. I added this. I created a adjacency list. I made this adjacency list. Fine. I created a map of character corresponding to that vector. Okay. Yes. I was thinking the same thing. Character and the node list 7 3 and all of that. Yeah. So I call this helper map. Starting from 0 adjacency list, this map will be filled up. This S is Radhya Verma. Hello, Jai Shri Ram. जय श्री राम शुभम भाई, जय श्री राम. सॉरी मैंने चैट देखा नहीं. हेलो अंकल, गुड मॉर्निंग. हैप्पी दिवाली. हैप्पी दिवाली आराध्या. आराध्या वर्मा. I'm creating this helper. Okay, let's see what this helper is doing. It's very small. स्ट्रीम कब तक चलेगा? प्रोबेबली डिपेंड्स ऑन मी कि हम कब तक चला रहे हैं. बट पॉसिबली 3-4 बजे तक तो चलेगा. उसके बाद okay. Okay, so what exactly we are doing is, let's see, I am going to its adjacent node, calling this helper method again. It's fine. Is something going from top, not from recursing back we are doing. Continue with the stream. Yes, I am continuing with the stream, but I don't see you are studying. Okay, so we added that node in the map. We are calling the helper. Now what will happen is, if that specific node inside map has something, mm, and sister, what exactly is doing? Why is my solution TLing? I don't know, bro. Why your solution is TLing? So we have this ancestor. Oh man, this is some kind of weird question, I would say. Helper 2 is easy. It's not nothing new. My helper 2, like DFS sum, is fine. I'm fine with this DFS sum. I don't have anything to do with DFS sum, but I do. So this is he is doing what is iterating from start. I got a value. That value he is updating and then calling the next. So he is doing something from top. So I'm pushing this node on based on this character. I'm pushing this node. Yes, correct. Then I'm calling and I'm popping. When I'm falling back from here, I am removing this node. So it will eventually becomes empty. So it will eventually become empty, and but the character will be there. That's why I'm checking if if it has some value in it. That character contains some value. If it is, if that node's character contains some value, what I'll do is I'll create an ancestor. Uh, the last one. I'm picking up the last one from that vector, and this new node, the node that I went to, is populated with this new ancestor. Oh, okay. So he did what? Instead of starting from back, he started from top. that helped him. How it helped him? Let's. It was really nice way. Nicely he handled that part. So I have this character and this node list. So when I'm going, I am doing what? B character with node. So if I see again B, I'm telling you this. I'm telling that I have seen B previously. This will be called back. I have seen B previously, and you are now uh, 2 is 0 is now your parent. So in my parent map, I'll update for 2 as 0, and I'll add push 2 also. Then I went here for 12. I'm telling that I have seen nodes, and 2 was the latest node that I have for you. So your parent is now 2. So 12 parent is now 2, which is fine till now, because it's B only we are continuing with. Now I'll add here at this position B with 0, 2 and 12, and I'll push. I'll go back here again. Now 7. I saw that I have seen that character, and the last was 12. I'm telling you that the parent for you is 12. Perfect. Seriously, this is really a good way. And when I fall back from here, when I'm falling back, I'm popping the last character from here. So uh, for these all, I'm no when I'm so when there's no child, when I fall back, I removed 7, but there is 12 still. I shouldn't have removed it here only. After pushing, I'll call everything, and after calling everything, I excuse me. For 12, I'll go 3. I will check whether A is present or not. No. If this would have been B, I I would have to connect this with this 12, right? Okay. Let's see this. Um, what I'm saying is I need. Not returning anything. I want. Okay, just a second. I had these things. Let it be here. I do not want to return anything. So I need a map of character corresponding to that vector of integer. Do I need it here? No, I do not need it here. Instead I'll create here what I was creating with this. I'll create with this. So okay, let's pass it here only so that I can have it as pass by reference. Ampersand, this will be something character matching with node. So char node, what I'll do this char node dot char node of this character. So character I have from s, so s of node will give me the character dot push back this node, and after calling its child I'll say that char node s of node dot push back pop back. So last character will be removed from here. So I'll check in my map if this char node of this in this character, so character is nothing but s of node dot size is greater than 0. That means if there is any value present, so parent will be updated for that. So that means parent parent of this new node, this node will be what we have in my char node. So char node of s of node dot back last value will be now parent of this node and sister. And sister is something like and sister, and now its child will be explored. After exploring all of its child, I'll pop back. Okay, so pre-calculate will having unordered map of character corresponding to vector of integer char node I'll pass this here where I'm taking before parent. Okay, so pre-calculate is what I'm starting from 0. 9 1 15 2 3 1 1 5 2 4. It's working fine. Let's submit it. Now why it is stealing? I'm passing this as ampersand. Parent is also address. This node will not be address, obviously. New adjacency list. But why? And do you think that the solution will work? Yes, it is, but it's taking 3000 3 millisecond 3 second. No, it is also exceeding time limit. Weird, huh? How 4647 were accepted? Not sure. This question is like You think your solution is going to work? Will not give me really. Oh, 27 millisecond. That means your solution will work. If it is 27 millisecond, this will work. But how he did that? It's like how so many people are able to solve this question and was not able to solve that question. I'm just confused. Like medium is this something they see medium and they try it, and if they see hard, they don't try it. I don't know. Okay, I'll take a 10 minutes of break and then I'll start with maximum points tourist can earn. I am also confused. Yes, I guess you will be confused all the time. Stay confused, brother. It's always better to be confused. जब आते हैं तो break ले लेते हो. Bro, that's not my problem. I think that is your problem. You are coming in wrong time. Happy Diwali कौन बोले? Happy Diwali. Happy Diwali, bro. Happy Diwali. चलो पार्टी दो अब. हाँ, नहीं, आई थिंक ना हो पाएगा पार्टी वाला तो. मैं आया ही नहीं. अब तुम्हें क्या लग रहा है कि मैं किधर हूँ? हैदराबाद में हूँ, मैं रांची में हूँ. व्हाट डू यू थिंक वेयर आई एम? Bro, I don't see you streaming, bro. When will you stream? I'm waiting for your stream. That day to come when you will stream, and I'll watch your stream. Something like that. Will that day be soon or not sure? Bro, you are not replying. I'm going to take a break. Okay. Bye. I'm on a break for a few months. Planning to be back by February. Seriously, you're planning to be back on February? Great. आओ ब्रेक के बाद. Okay. Stay here. Don't go anywhere. I'll be back after break. Okay, I am back. I'm happy that still I got 14 views on Diwali day, 8 likes. It's great. Okay, let's go to the next question. Okay, maximum points tourist can earn. Let's see. Last question was insane, and this question would be something like that only. Okay, expecting that I'll get some intuition this time. You're given two integers n and k. It's fine. Along with two 2D integer arrays. Okay, we are getting two 2D integer arrays. Fine. Stay course and travel course. A tourist is visiting a country. A tourist is visiting a country with n cities. A tourist is visiting a country with n cities, where each city is directly connected to every other city. Okay, the tourist journey consists of exactly k, zero indexed. They can choose any city as their starting point. Okay, any city can be chosen as its starting point. Each day the tourist has two choices: stay in the current city. If the tourist stays in the current city, their current during day I, they will earn stay course I current points. Okay, move to another city. If the tourist moves to their current city to city destination, okay, they will earn this much point. Return the maximum possible point the tourist can earn. Mm-hmm. Let's understand with this second example, a better one. Stay course and travel course. A tourist visiting a country and with n cities. Okay, there is a country with like multiple cities. We have where each city is directly connected to every other city. Okay, so each city is directly connected to every other city. I can like go from any city to any city. It's like kind of thing. Okay, every city is connected to every other city. A direct connection is there. So the journey consists of exactly k days, and they can choose any city as their starting point. Okay, starting point can be any city, doesn't matter. Okay, and if I stay in the city, if the tourist stays in their current city, current during day I, they will earn stay score I current points. Move to another city. If the tourist moves to their current city, current to city destination, they will earn travel score current destination point. Okay, so let's see what happens. So there are three cities in a country, and I have 2 days. If I stay here, the tourist earns the maximum number of points by starting in city 1. Each day, the tourist has 3 choices. Okay, stay course 0, 1, and 2, and 0, 1, and 2. This is 0, 1, and 2. So these are cities we are talking about. So if we start with 0, if we stay in 0, city 0, then 3 points will be earned. So 2 days. Why this has 2D array? I have 2 city. So city 0, city 1. City 0, city 1, city 0, city 1. I need to understand why it's 2D. Stays in the current city. So suppose my current city is 0. During day I. So this is somewhat day 0, 1. So why traveling is something from current city I am going to destination city. So cities, these are cities 0, 1, and 2. Travel score. This is what my day is. And this is what my city is. So I can start any city. So I can start from city 0, city 1, city 2. I have any of the option. Okay, I suppose this is my day 0. I'm on day 0. I can start with any of the city. Correct. City 0, city 1, city 2. Okay. So suppose we have city. I started with city. So like this is day. This is my city. Day 1 will also have 3 choices, kind of thing. Not sure 3 choices. Let's see. So I on 0th day I will start with suppose city 1. So if I stay in city 1 only, what maximum that we can attain? The maximum value that we can attain is 3. Day 0, city 0. If day 0, city 1, 4. If day 0, city 2, that is 2. Any day will not is not the option, because obviously I'm going to pick. Uh, I will start from start day, 0th day, because the more days will stay, the more number of score will get. So I'll start with the 0th day, day 0. Uh, if I want to travel from, uh, okay, so if I stay at city 0, city 1, city 2, if I if I want to travel from current city to destination city, so there is something from city 0. If I travel to city 1 and 2, so it will happen 0 of 1, which is 2 cost. Tourist earns the maximum number of points by starting in city 1, staying in that city on day 0. Okay, so day 0, city 1, 4 point, and traveling to city 2 on day 1. So from city 1 to city 2 on day 2, on day 1. So from 4, current city is 1, 1 to I'm traveling to 2, 1 of 2, which is 4. So 4 plus 4, that is 8. Okay. N can be 200, K can be 200. Stay so score IJ can be a value of under 100. Travel also will be under 100. Travel score II will be 0. Traveling from same city to same city is obviously going to be 0. So this kind of looks to me like a dynamic programming approach, where I have 3 cities, I have 2 days. So days, depending on days, day 0, I can start with any of the cities. Okay, day 0 with any of the cities. So if I'm starting from 0, then okay, it's something choices. We have multiple choices that, let's see, this is my day 0. If I'm at day 0, I can start with 0, 1 or 2, any of the city in that country. So if I suppose start with 0, there will be option 1 to stay in the same city, which will eventually earn you something. On day 0 we are talking about, or from 0 I can go to 0, From 0 I can go to 1, from 0 I can go to 2, because there are 3 cities, so 3 till 3 values we can iterate over. Now from 1 also we'll have 4 choices, we'll have few choices. First, stay there. Else, go to city 0, from 1 go to city 1, go to city 2. um, so if I'm going to city, and same thing for 2, I have few choices. One, to stay there, or that day move to another city. Okay. And from wherever we are getting the maximum value, uh, we'll store that maximum value and return that maximum kind of thing. I have total number of these many cities. I can start with any of the cities, right? On day 0. So I can start. Whosoever will give me the maximum result will be uh, and max answer is currently 0, so my max answer would be kind of maximum of max answer, and whatever we'll get from the recursion, and I'll return my max answer. So let's try to build the recursive part first, and after that I'll try to memorize that thing. So okay, so how can we build the recursive part? Let's try to travel points, max travel point kind of thing, max travel points. This will take what? This will take few things, that is which city currently I am, which will indicate me total number of cities that I have here, which day we are okay, which city I am, which day I am on, which what is the maximum day, right? What is the stay score, uh, and what is the travel score. So we need these things with us. I'll return integer. I'm only having integer. So let's see. We are talking about which city, means current city. What is my current city? Erase this for now. Okay, so what is the current city? What is the current day? Means current day I have. What is total city? What is total days? How many total days we have? Total days. Okay. Now I need this travel score and stay score. That will be passed away. Can't we increase the size of this? Okay, fine. So I need to have some base case that if days, all the days are finished, if kind of current day matches with my total days that we have, then we need to do something like this is the end, or even current day goes beyond that, then also that is the end. So so let's see, because I'm starting with 0 day, so it'll be equals to, so at that moment of time I think I should return 0, and let's see what things I'll be changing if current day matches with total number of days. Now there are two options, either stay here or to travel another city. Correct. If I'm staying here, my day will change. Like on 0th day I stayed there, so if I'm staying there, my score will be kind of stay score will be from stay score, uh, max score currently I have is 0. So if I decided to stay here only, so what I will add in my max score will be maximum of max score comma staying there will be like on current day. What is my current day? So stay score of current day with current city, that will give me the stay score, plus I'll call my max travel point for the next day. For the second day. Okay, so max travel point will be I'm staying in the current city only, so current city will not change. My day will increase, so my current day will go +1. Total city will be as it is, total number of days will be as it is, stay score will be as it is, and travel score will be as it is. Correct. Now, I want to travel another city. From this city, I'm traveling another city. What's the point? What's the score that will I will get? So, what all cities I can explore? And I can explore from I is equals to 1. I is lesser than total city. Obviously, going to the same city will cost me 0 point, and I need some maximum point. So, I'm traveling to other cities. I'm trying to travel to other cities. So, it will be somewhat max score, which will be maximum of max score, or I'm traveling to another city, so that will be from my travel score. Current city which I am in, and the city which I want to go, that is my destination city. So maybe city. Destination city is nothing but I. Destination city. So that is my score, and then I'll call my max travel points. So now I'm in my I traveled from current city to destination city. So my city is changing. So the new city is destination city, right? Current day will also increase because days will pass. Current day +1, and total number of city will be as it is, and total days will also be as it is. Okay, and at last I'll be returning my max score. So whatever max answer will have, that will be my max score. Let's see, I haven't memoized it yet. Okay, fewer arguments. Expected 6 have 4. Where? Current city, current day, total city, total day, stay score, travel score. So we have 1, 2, 3, 4, 5, 6, 6. Okay. Oh, sorry. This stay score and travel score will also be passed. Okay, so we are getting 3 and 8, which is expected. Now I need to memorize this. So what are the things that are changing over here? The things that are changing is current city, current day. These are the two things that I have. So maybe I'll do my memoization on those cities. So int memo, uh, current city is can go up to 201. Days can also go up to 200. So I'll do a 2 DDP. Let's see. Mem set memo -1, size of memo, and here if memo of current city corresponding current day is not equals -1, I'll return. And at last I'll store it over here and I'll return. Let's see if everything is good. Okay, 3 8, fine. We are expecting that only. Seems good to me. Okay, let's submit it and see. Accepted. Perfect. 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 So this was like, the question was not that difficult, I would say. The previous question was much more complex in coding wise. This question was not that much complex in coding wise. Uh, the only thing that you need to know is dynamic programming. If you know dynamic programming, if you know how to handle these things, you can like break down into parts, and you can solve it. So this was not, this was a good question, but we solved it in a good way. So nice. Mm, okay. So this is done. We were at least able to solve two questions. Okay. Not pretty much sure if I'll pick the third one, the harder one. Only 150 was able to solve them. It's quite. Find the original typed string. Is it the first? Okay, okay. It's the same question. One, and it took 20 minutes for them also to solve. I think the maximum time, my time spent was on this second question. This was like still the not the easier part, easier side, I would say. But okay, fine. Okay, I'll be back in a minute. Don't go anywhere. I'll be back in a minute. Came back. I brought something to eat. Actually, I was feeling a little hungry. Okay. We have weekly contest 420. Let's try this question also. So this has 4.4 first, second, third. Okay. Let's try to solve this in the minutes that we have, if possible. So find the sequence of strings appeared on the screen. You are given a string target. Okay, I have a string target. Alice is going to type target on her computer. Okay, Alice will type target on her computer using a special keyboard that has two keys. Okay, only two keys. Key 1 appends the character A to the string on the screen. Okay. Key 2 changes the last character of the string on the screen to its next character in the English alphabet. For example, C changes to D and Z changes to, like, it'll round off to A. Note that initially there is an empty string on the screen. She can only press key 1. Press key 1. Okay, so first time she has to press key 1. Okay, obviously pressing key 2 means nothing. So return a list of all string that appears on the screen as Alice types target. Okay. In the order they appear using the minimum key presses. So what's the target length? It's 400. Maybe I'll go with the BFS approach. Initially it's empty. I'll add A to it. The next time I can have is adding A with A or A with B. I might check a condition that if I'm pressing the second key and then the index that we are pressing on, it should not cross the index that on the target that we have. Like we already have B and we pressed it, it turned into C. I don't want that because obviously that will not make any kind of sense to us. So I'm thinking of like going with a BFS approach, breadth first search approach for this, where I'll start pending A, and it'll be have will have two append new addition after the first appending. Uh, it will be like A will change to B, and a new A will be appended to that character. So that also depends on the index that we are having. So it will take possibly time complexity will be every characters. Suppose there are Z characters, so will I ever have to do this Z changes to A? round up. I don't think I have to do this round up thing. I'm pretty much sure about it that roundup thing will not occur here. So what we can do is we can create a queue. Mm, that will contain that will contain appended a last character, and what is the size, which will tell me the index. Okay, so a vector of string, possibly what I want as output also. So initially like kind of I'll push a because I need a. So q dot push uh, kind of inside a vector a. I'm just checking that this is not a wrong way to. Okay, fine. So it'll always be possible. That's one thing that I'm pretty much sure about it. That it will be possible always. So now while not q dot empty, what I will take is vector of string current current like keys pressed, or current string, maybe current string str list, which I'll take q dot front. So I'll fetch it from front. I have this. I'll take the last one. So it will be like string current string, which is current string list dot back. They'll give me the current string. I'll pop this from queue. I don't need this now. Now I need to have the index also. And like current idx. What will be the current idx is current str dot size -1. That will give me the current index. I'll pop. Now one thing that I need to make sure, if current string is equals to my target, I'll simply return current string list. If it is not, there are I'll be having to key press 1, key pressed 1, and key pressed 2. See, we are pressing key 1. That means we are appending. So something I need to check. Do we have to press key 1? Because if it is increasing my target size, I should not. So if my current string dot size is is lesser than my target dot size, then only I'll be pressing key 1, because that doesn't mean anything if we press again that key. So if current size is, so I'll press the first key, which will do what, which will add a new a to this string. So this will be new string that we are making, which will be current string plus a. This is my new string, and now I need to push this from inside my current string list and push it to queue. Current str list dot push back new str and q dot push this new str, not new str, current str list, and I'll have to pop it also, current str list dot pop back. So if we press this new button, this will happen. Now if we press press button 2, so if we press button 2, what will happen is the character will increase, the character value will increase, last character value. It will not append anything, but it will. So current string index, let's use this index. Now what I will do is if the value at current string index, like, so if we have this current string idx is lesser than target of idx. That means I'm saying that if the value is smaller, then I can do something, else I'll not do anything. So if it is smaller, then I should be pressing key 2. So this will do what? This will create a new string which will do what? I need so new str character ch is equals to new str of this index plus 1 1 1, which will increase to the new character. So new str dot pop back, that will remove the last character, and new str is equals to new str plus this ch, and q dot push so before pushing it to q, I need to pop back this current and I will be pushing this new string, and current str list will be pushed over here, and and maybe I'll do it again. I don't know if doing this will not change anything. This doesn't mean anything because this will eventually be emptied. Let's see. Okay, it's current IDX. Okay. It's kind of going in the same way. I misunderstood the question. So I'm changing it. I should not remove it. I should directly add it. This is increasing. We repeatedly press key to increment. Obviously, yeah. This VFS is wrong. We are taking lots of space. Why to waste those many space? Okay. What I'll do is I'm little feeling hungry. I'll take a long break, and after that I'll be back. Change to 30 minutes, and then we'll start again. So I'll be back in 30 minutes, and then we can continue again. See ya in 30 minutes. I am back. Sorry, little late. Okay, so this was so dumb. I feel so dumb on myself that it's kind of mm, very much dumb approach that I used here. Should have you not used this dumb approach. Just a second. Okay, so let's try it. Let's try adding characters, and if it is not same, I'll increase the characters and push it into my vector string. Okay, so initially my result dot pushback would be a, and I'll start with so I'll add this a over here. Sorry, what happened? Okay, I'll add a every time and I'll check until and unless it is same. So while uh, target of I is not equals to result of I, no uh, what I'm doing is I pushed a, I'll also take just a second. Let me think over it. I added a in my array, and until and unless it is equals to b, I will iterate, and after doing that, the last one I pick, I'll add a to it again, and until and unless that character is equals to, I'll add and I'll push it in my queue. Okay, so I'll take a string. I'll result dot size is equals to 0, or I'm fetching the last character, last string. So string last str will be kind of so result dot pushback. I'm little going confused over here. Okay, just I'm trying to make things easier for me. I don't want it to be confused. So I have to confuse. So I'm taking the last string from my result. So result dot back. This will give me the last string. Okay, now it's I think it should work. Result dot size is greater than 0. This is the case, then result dot back, else empty. So last string is empty. What I will do is last str is equals to last str plus a. I'll add a. Now uh, I will be, so instead of result it should be last str of I. If they are not same, so last str of I will be updated with last str of I plus 1, and I'll push it in my result dot push back last str at last. I'll return result. So my result is empty, so last str will be empty. I added a to it. That means last str is 0 now. So last str of 0 uh, is not equals to target of I. So this is equals to target of I. Just a minute, I'll be back in a minute. I'm back. Well, okay, what wrong I am doing? I have nothing. I added A to it, and that will be pushed. And now, if not same, I'll I'll add one to it until unless it is same, and I'll keep pushing it. So use test case. Let us see. Okay, let's go 5 5. Okay, count substring with k frequency characters 1. So we are given a string s and integer k. Return the total number of substring of s where at least one character appears at least k times. Okay, so I need to return all the substring where one character appears at least k times, right? Okay, okay. Okay, so A B A C B. It is kind of very simple. I'll use an unordered map. Let's do it quickly. Let's not waste time. In this, I have a character. I have an integer. uh, Char frequency map. Character frequency map. This is. So what I will do, I'll start iterating over this array. Uh, Instead of too much background noise. Okay, great. Mute the speaker and try to solve the question on your own, bro. Why don't you try it? No, cooler is not on. Only fan is on. Now you are having problem with me streaming also, huh? Hey bro, like with some of your other accounts, no, I have only got 8 likes. I need 10 at least. I need 2 more accounts, please. So this is character frequency map. I'll have two things, left and right. Now while my right is lesser than s dot size, while my right is lesser than s dot. Bro, you left me? Good. Wow. At least k times, right? So ABA1, 2, and 3. One, two, three, four, 5, 6, 7, 8, 9, 10, 15. Okay, a little bit of twist is there. So I added in my character frequency map this new character. So SFR will be added, and plus plus. Now there is one thing, that while this character frequency is more than k, at least k times, means equals to, greater than or equals to k. So while char frequency map of S of R is greater than equals to k, what I am doing is I'm adding in my answer everything after right, means kind of, if we have these three as my left and right pointer, so how many answer will be there? 3, right? So how did we calculate? 1, 2, 3, 4, 5, total 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115 5 minus 0 1 2. 5 minus 2, that is whatever size will be added. So let's take int n is equals to s dot size answer plus is equals to mm, n minus right index, that will be added in my answer. And what I will do is character frequency map of s of l. I'll try to reduce and increase. Okay, and there is few test cases that I want to check whether if there are a b b b c c c d s b or a. Oh, perfect. Minimum division operations to make array non-decreasing. Or given an integer array nums, any positive divisor of a natural number x is that is strictly lesser than x is called a proper divisor. For example, 2 is a proper divisor of 4, while 6 is not a proper divisor of 6. Strictly lesser than we are talking about. Okay. You are allowed to perform an operation any number of times on nums, where in each operation you select any one element from nums and divide it by its greatest proper divisor. Return the minimum number of operations required to make the array non-decreasing. Okay. So there is one thing that I'm pretty much sure, that if this is a number 6, I cannot increase this number, I need to reduce this number. So all the rest of the numbers should be equal to or lesser than this number, large number. So the way I'm thinking of approaching is from the end. not from the start. So from end I'll have 6 as a fixed number. I'll not reduce it because obviously that is the largest number that I have till now. I'll move to second largest number, sorry, second last number, and try to reduce it below or even equals to the number just next to it. So I'll try to reduce 7 to 6, and I need to find proper divisor for that. So proper divisor is kind of the largest number uh, that we can find, which will divide 7 eventually. So I think the main crux here is to find the proper divisor. So for proper divisor, which actually divides it and do not divide. Okay. So so proper divisor, like for 30, the proper divisor is let's say 15, the largest proper divisor. So we need to somehow find 15. So we cannot like something do start from the from 2 and go till that number and check every possibilities. So like 30, what number possible numbers we can divide 32? So we have this number 30. So if we try from last, uh, I need to find a proper divisor for this. If I like try to square root it and check, so what's the square root of this will be? It will be nearly 5 point something, which will eventually be 5, right? Okay, so we have numbers from 2 to 5, I guess, after square rooting. So square rooting 30 will give me somewhere 5, which will tell me that 2 to 5, I can check 2 to 5. So if 2 can divide 30, the other number will be 2 divided by 30, that is 15. 2 divided by 30, that will be 15, right? Right. Okay, so 30, if it is divisible by 2, uh, yes, it is divisible, then the other number will be 30 is divisible by 2, is it? Yes, then 30 by 2. So the lowest number I find, the largest number I'll get. I'll stop there. So 15 is what I will get. So I know that 15 multiplied by 2 will give me 30. So I got that number. 15. I'll stop there. I do not have to go further. So similarly for for 25, if I see, square root of 25 would be 5. 25 is now for 25, the sqrt square root of 25 is equals to 5, which will tell me I can iterate from 2 to 5. Is can we divide 25 by 2? No. 3 by 3? No. By 4? No. By 5? Yes. So this is the only number that I can divide. So if we divide 5 by 25, then both the numbers are still 5. 5 divided by 25, that will give me 5. So 30 divided by 2 will give me 15, and 25 divided by 5 will give me 5 eventually. So both the numbers are same. So whosoever is like the larger one, I'll pick that one. So I think this is the way how I will start. And I'll try to keep it. See, I have to divide it by the largest proper number once. That will reduce it to 2. If there would have been 30 and 7, that would reduce it down to 2. I need to do one operation. So okay, let's see. So I'll have a result. Now for int I will start from second last number. I'll take size as nums dot size minus 2. Let it be nums dot size only, and minus 2. I'll start. It will go till greater than equals to minus I. Now what I need to do is I need to find the square root. So sqrt square root number, which is like I need to check first if nums of I is greater than nums of I plus 1. If that is the case, then only I'll be doing it, else I would have simply continued from there. So I'll try to find the square root of that number. So square root of nums of I, which is nothing but sqrt square root of nums of I. Now I need to iterate from like largest proper divisor. I need to find the largest proper divisor. Find proper divisor of nums of I, starting from square root of num. So maybe I don't need this. This can be calculated over there only. Okay. Find proper divisor and value, I have this value. I'll square root this value. I'll start from 2. I'll go till equals to sqrt square root of num plus I. I'll I'll increase the number one by one. Now what I need to check is whether the number is divisible by this number or not. So if value modulo I, if it is giving me 0, that means the remainder is 0 after dividing it, that means I can divide. So I can return value divided by I, and if not, I'll simply return -1, that it's not possible. So if largest, let's see, largest proper divisor is equals to -1, that means I was not able to find it. I'll simply return -1, that I can't do it. Not possible for this case. If it is not, we found something. Now I need to reduce this number that much until and unless I reach a number lesser than nums of I plus 1. So while I'm not sure if reducing it on dividing it only once will reduce the number from at no, it's not always possible, right? So something like 1 divided by 5. I can reduce the number. Can I reduce the number to 0? Like if the last number is 0, can I reduce the number to 0? Just for example, return 0, and if I have 0 over here, so I should be having a value from 1. What if I have 1? Why this came out to be -1? What is the reason for this? I found 5. I divided it by 5. In operation any number of times. And in each operation you select any one element of nums and divide it by greatest proper divisor. So if only in ones I'm not able to reach. So if it is 4, even 4, I'll return -1, because after dividing it's still greater than 4. Yes, so should I divide it again with that number? After dividing we'll get 5. If I divide it by 5 again, we'll get 1. So maybe not. Let's check. So I have this largest proper divisor. So if dividing this number and divided number is something nums of I divided by largest proper divisor. So if divi- divided number is still greater than nums of I plus 1, then also I'll return -1. That this is also not possible. Else what I will do is I'll make this nums of I equals to divided number. So check for 30, if we have 4, that should return me -1. No, uh, it should, if it is 1, and if it was 4, mm, and I'll increase my result, result plus plus, and at last I'll return my result. Accepted. Okay. Okay, so I was able to solve both of the question. Okay, let's take a 10 minutes of break, and after that I'll try to go for 2 more sessions. Let's see if possible or not. Then I'll stop for today. So I'll take a short break. I'll be back soon. Don't go anywhere. Back. Okay, I'm back. So we were able to solve this question. We were able to solve this question. Close it. Close it. Close this. Close this. We were also able to solve this question. Okay, let's go to next contest. Wait, go back. 419. This is called upsolving. We are doing upsolving of the same questions. Okay. Three, nine. Let's go 4, 5, and 6. Try. Okay, there are lots of trees related question these days, huh? Don't you think so? We got a tree related question today also. This is also tree related. Let's see. You are given the root of a binary tree and an integer k. Cool. So we are given a root of a binary tree and an integer k. Return an integer. Okay, we have to return an integer denoting the size of the kth largest perfect binary subtree. Return an integer denoting the size of the I need to return an integer denoting the size of the kth largest perfect binary subtree, or -1 if it doesn't exist. Okay, a perfect binary tree is a tree where all the leaves are on the same level and every parent has two children. The roots of the perfect binary tree subtree are highlighted in black. The sizes in non-increasing order are 3, 3, 1, 1, 1, 1, 1, 1. 3, 3, 1, 1. And then what is 4 times 1, 1? What is this? Are we talking about this? This. Denoting the kth largest perfect binary subtree. So we need to find kind of kth largest. Okay, let us see. One largest size is 7. Number of nodes is 7, obviously. Okay, so now if a binary tree is perfect, it should follow some kind of specific rules on the number of nodes. So there should be a specific pattern on the number of nodes which it should follow. So it should be kind of like 2 to the power n minus 1, based on the level. We are talking about the level. So n is nothing but level, I would say. So from back, if I traverse back, I need to know what is the current level. So how many nodes will be there? So at this position, if I see at this position, I'll have something 4. For 4, the level is kind of 1. So level is 1. How many nodes should be there at level 1? So 2 to the power 1 minus 1, that is nothing but 2 minus 1, that is 1. So one node should be there. Is there one node over here? Yes, there is one node. Uh, so I need to track the level as well as the number of nodes. So based on that level, the total number of nodes, how many nodes are there below that. If it is matching, I would say that that is the level. That is a perfect binary tree. I might try to insert it into some kind of a priority queue which will keep the kth largest at the top. So I'll only keep k total elements in the priority queue. So uh, while recursing back, I'll keep two things in my mind, that what level I am currently on and how many nodes do we have, right? Okay. Okay, so I need to do this. So every time I will fall back, I'll keep two things: total number of nodes, including this, maybe or not, doesn't matter. But what is the level currently we are on? So whenever we find nothing, we'll say that we'll return level as 1. So and after that we'll go back level and add node to it. So it's something like that. So every time uh, at every level we'll keep a priority queue, which in which I want the top values to be the smallest. So priority queue will contain integer, vector integer, and I need the smallest value at the top. Okay, now what I will do, I'll start my iteration. I'll start calling the recursive call for the binary tree. Maybe find perfect subtrees. Okay, find perfect subtree. So here what I'll pass is my root node, my k, my priority queue, and after everything, if there is no, then what? Or negative one if it doesn't exist. Okay, so uh, if pq dot size is lesser than k that we didn't reach, return negative one, or else return pq dot top. Okay, now let's write the find perfect subtree. Okay, there is one thing that I need to handle, like when we reach at the node. Let's see if that part is also being handled by me or not. So this will be returning two type of thing in a pair. The left part is something, I would say, level. I need level, and the second part will be nothing but total nodes, total nodes, node count or something like that. Okay, so I have this tree node asterisk as root. I'll start with my root. I have this k already. I need to declare this priority queue. Now if not root, if there is no root, I need to return something. So return what? Return at level 1. We are at level 1, so level will be returned as 1, number of nodes will be returned as 0. Well, there was no 0, now we have returned to level 1. Two calls, everyone will take pair as a response. Left call, left, maybe not call, find perfect subtree. Root ka left k and priority queue will go as it is. Find perfect subtree will go root right, k and priority queue. Now we are getting something from left, we are getting something from right, and total nodes till now will be now I need to do some iterations and check. So int total nodes will be left of first, sorry, left of second. see, the level will always will take as the maximum, because if there is no level on the right, from left if I got a level, I should be taking the maximum level, because that maximum level, that many nodes should be there. And if even if the level from left and from right are not same, um, that will also conclude that uh, yes, and that can also be one of the things. If left level is not equals to my right level, no, no, it's not always true, right? I will have to send the maximum level. No, that will always not going to always be true. So total nodes will be left of second plus right of second, and level is nothing but maximum of uh, one more, including the node which I am on, right? So level is something maximum of left of first, comma right of first. So the maximum level, that many nodes should be there, right? So I have this level. I need to find how many nodes, optimally how many nodes would have been there if my level is this. So if kind of optimal nodes, optimal total nodes, optimal total nodes will be like power of pow function will give me like 2 to the power n, 2 to the power like level minus 1. So that will give me optimal total nodes. Now if optimal total nodes is equals to the total nodes that we have, if that is correct, that means this is a perfect sub binary tree. uh, so if that is true, then I'll try to push it in my priority queue. So if priority queue dot empty, if it is empty, or pq dot size is kind of lesser than k, in that case I'll simply push optimal or total nodes in my priority queue. Else if pq dot size is equals to k, if it is equals to k, and the total number of nodes is greater than, if the total number of nodes is greater than pq dot top, what should I do? Then I'll pop my priority queue. I'll push total nodes in my priority queue. Now I need to return. So total nodes that we got till now, that will be returned, and level plus 1. So returning will be level plus 1 and total nodes from here. Okay. Perfect. So this question was also not bad. Like nearly 15, 16 to 17 minutes. My head is really paining. I don't know why. I need some rest. Maybe I think I should stop now. Uh, I'll continue. I'll be back tomorrow. I'll be streaming back to back. So I'm thinking of stopping for now. Uh, I'll see you see you tomorrow uh, in the morning, 9:30. I need to go outside also to buy diyas and all for Diwali. So I need some rest for now. So I'll take a nap for like half an hour or 45 minutes or something, and after that I'll go out and enjoy Diwali today. So I hope we learned a lot of things today. We were able to solve questions, lots of new questions, and we were able to solve many of them, but still we were not up to that mark. We need to reach to that mark level. We'll try our best. I will start from this. I think count the number of winning subsequence, or maybe I'll try this in the evening. I don't know if I'll try this in evening. Tomorrow I'll start with fresh something new. But if I'm trying this not today, I'll try this tomorrow on the stream. So see you tomorrow, same time. Hopefully 9:30. We'll be back again. Bye bye. Have a great Diwali. Happy Diwali. Happy Diwali to everyone. Bye bye.